All right, so today we'll take a look at similar figures. So we're going to learn the different properties of similar figures. And what similar figures basically are is that they are figures that have the same shape. So if we're looking at a triangle, it's compared to another triangle, but it has a different size. So it's either going to be bigger or smaller. Now here's some things we have to remember about similar figures. So similar figures have corresponding angles, and these angles are congruent. And what that means is that this angle A and this angle D, they're corresponding because they're in the same location and they're congruent. Another thing is that they have corresponding sides and they are proportional. So we're going to set up some proportions and prove that. And the ratio that's created for these corresponding sides that are proportional, the thing that makes them either bigger or smaller is called the scale factor. And the scale factor is basically a multiplier. It's whatever the numbers were multiplied by and either to make it bigger or smaller. So let's take a look at some of these examples really quick. So the first property we're going to look at are the corresponding angles. So what I'm going to do in order for me to find what's corresponding, I'm going to use a highlighter for each one of these sides. So for example, you kind of have to imagine it like a seating chart. So these three students, 4, 5, and 7, are sitting at different sides of the table. And then other students, 8, 10, and 14, are sitting at another table, but at the similar side or corresponding sides. So for example, student 7, so I'm going to highlight him in green. Student 7, he corresponds with student 14. And then student 4, he corresponds with student 8. See how they're sitting at different tables, but on the same side? And then finally, student 5, he corresponds with student 10. So you can kind of imagine you're sitting at these tables and you figure out who's corresponding with who. So we're going to use that idea of corresponding sides and corresponding angles to help us answer these questions. So A is corresponding with D. So those angles, those two, angle A and angle D, they are congruent, they equal each other. So for example, we have angle A is congruent to angle D. So let's say, for example, if this one is 30 degrees, this one also has to be 30 degrees because they're the same. So this next one, we have angle B is congruent to angle E because see that they're both at the top and they both have a yellow and an orange side partner. Then finally we have angle angle C is congruent to angle F. All right, so let's go ahead and move on. Now that we know corresponding sides, or corresponding parts, I guess better to say, and we have these corresponding angles, now we can move on to the corresponding sides and the relationships. Okay, so let's figure this out. So I'm gonna start out with side AB, this side right here, AB. So side AB corresponds with side DF. So you kind of have to imagine it like this is my first shape and this is my second shape, right? So this is my first, this is my second. So first we start with A, then we go down to DF. Oh, I'm sorry, actually that should be DE. There we go, that makes more sense. So AB goes with DE. Let's go ahead and highlight that so we know exactly what we're talking about. So we have AB and DE. There we go, much better. So let's go ahead and move on to the second side. The second side I'm gonna take a look at is BC. So BC, right here, corresponds with EF. Just like that. So BC, it's in orange, corresponds with EF that is also in orange. Okay, then the last side is gonna be AC, and that corresponds with DF. I'm gonna make that side both green, just like that. All right, so now that we have corresponding angles, we have corresponding sides, let's take a look at the scale factors that were used to figure this out. So in here it's asking, what is the scale factor of ABC, this first one, to DEF, the second one? So if I moved from this triangle to this triangle got larger, right? So what's the scale factor? What caused it to be bigger? Well, here's how we figure this out. So we take a look at the first shape, compare it to the second, and then we just pick one of the measurements. I'm gonna pick 4, and then to 8, 4 to 8. And then I'm gonna go ahead and highlight them so I know what I'm talking about. So that scale factor reduced is 1/2. There's a half of a scale factor there because all the numbers here are half as big as 8, or half as big as this triangle. So 4 is half of 8, 5 is half of 10, 7 is half of 14. Okay, what if we're going in the opposite direction? Well, if we're going in the opposite direction, scale factor, let's choose different numbers. I'm gonna start with DEF, so I'm gonna start with 10. So I'm gonna start with 10 this time. So 10 becomes 5. Okay, so how did 10 become 5? Well, that's a scale factor of 2/1 because I'm just reducing it. So it's a scale factor of 2. So in order to become this larger one, I had to double all my numbers, so I multiplied it by 2. And in order to go backwards, I have to half my number. So half to get to 5. All right, and so we'll take a look at different scale factors and how they affect different shapes here later on. Let's go ahead and move on to what they call the statement of similarity. So whenever you're talking about similar figures, you're gonna see this symbol, this little wavy symbol like that. That wavy symbol means that something is similar to something else. Okay, so how do you write that? Here's what it looks like. So the first 2 triangles that we looked at, so triangle ABC is similar to triangle DEF. Just a simple mathematical statement. What you'll see is that at the start of a lot of your similarity questions, you'll be given this statement. There won't be any words, it's just gonna say triangle ABC, symbol, triangle DEF. That this is all you're gonna see. Now, sometimes they'll say it in words, but in case they don't, you need to be able to recognize that statement, that mathematical statement. So now that we know that these properties exist for similar shapes, knowing that these are proportional and corresponding and that these angles are congruent, what type of question are we gonna see? Well, the type of question that we're gonna see is we're gonna be given 2 similar shapes, but we're gonna be given missing information or unknown information. So before I go ahead and make my my work to go ahead and solve for this missing side, I'm gonna go make my corresponding side. So I'm gonna pretend, again, this is like a table. I have student A, and he corresponds with student X. And then I have student 2 sitting at this table, and he corresponds with student 3 sitting at that table. All right, so now I can go ahead and find my unknown information. So if you might remember, we solve for unknown information using a WGU because we have what we're talking about, the given information, and the unknown information. So for similar figures, the what that we're talking about is always the first and the second shape because we're always talking about shapes. I'm gonna say this is the first one, this is the second one. So for my first shape, I can pick any side that I want to start with. I'm gonna go ahead and pick number 2. So 2 corresponds with 3. So from the first shape, I got 2. From the second shape, I got 3. Now I can move on. I'm gonna pick 8, and that turns into X. And then again, I'm just gonna go ahead and highlight everything so I'm able to keep track of where these numbers are coming from. So whenever you look back at your notes, you're able to know quickly, oh, they came from that side and that side. Okay, so how do we solve this? Well, we just go ahead and cross multiply and divide like we've been doing this whole year. So I'm gonna take 2 times X, that gives us 2X, 3 times 8, that gives us 24. And then I'm gonna divide both sides by the coefficient, and the coefficient is always the number connected to the variable. So in this case, it's 2. Then that leaves us with 12. So I know that the value of X, or the length of X, is 12. Now, one thing I want to mention really quickly is that whenever I was doing this, if you look at the shapes, they're oriented the same way. They're both oriented from left to right, up and down. But if you look at these little corner pieces, the little corners right here, see how they have the little swoops? These are called arcs. So whenever I was looking at this side connected to this side, if for some reason this was rotated or moved to one side or the other, I could still connect that this number 2 side connects with this number 3 side by looking at those arcs. So I'm looking for an arc and 2 arcs. So there's an arc and then 2 arcs. That's how I was able to connect them. Let's see this example in a more visual way. So here we have 2 triangles, and sure enough, one has been rotated. So the size has also changed, but the orientation, the way that it's oriented in space, has changed. So I'm gonna go ahead and see if I can correspond these sides first before I figure out the missing information. So I'm gonna say that side 8, he is between 2 arcs and a square. I look for 2 arcs and a square, and I know for a fact that 8 and 6 correspond. You can almost imagine it that 8 and 6 is being rotated out like that and then shrunk down a little bit to make it smaller. All right, so let's use our same logic and let's figure out X. He's between a square and 1 arc. So there's a square and 1 arc. I can go ahead and highlight that one. I know that those are connected. And then lastly, I have 17. Now he's the last side, so just by default, I know he has to go there. But in case I didn't, I knew that I have 2 arcs and 1, 2 arcs and 1. I know that side's the last side. So let's go ahead and set up our WGU to find out missing information. So I'm gonna go ahead and put WGU. I'm gonna go ahead and put down that this is my first shape, second shape. So this is first, this is second. And one thing that I wanna mention is that technically speaking, this one does not have to be your first shape. If you wanted to always start with the smaller one, you could. You can go ahead and say this one's your first and this is your second. I just like reading math left to right because that's the way it's supposed to be read. But in this instance, you can switch the order and it won't matter. You can make any orientation of sides that are corresponding. As long as the sides are truly corresponding, you'll always get the same answer. This just helps me with organizing my numbers. So my first shape, I'm gonna pick 8. So what does 8 turn into? 8 becomes 6, okay? And those are both the orange sides. And then I'm looking at X. Now I have to pick X. I mean, my other 2 sides, I normally get a choice on, but I have to choose X at some point. I can choose 8 or 17, doesn't matter, but I have to choose X for one of them. So X becomes 11.25. Now the cool part about being able to choose which side you start with and which side you use, you can technically avoid decimals sometimes. Other times, there's no avoiding them. 11.2 and X are connected. I have to use that decimal, but we'll be okay. Let's go ahead and cross multiply this to figure out our answer. So I have 6 times X is going to be 6X, and 8 times 11.2, that should give us 90. Then from there, of course, we do our division like we normally do, dividing by our coefficient of 6, and then that gives me 15. Okay. What I want you to do is pause the video and see if you could figure out the setup, the WGU, the proportional statement for these 2 shapes. And what I'll do is I'll highlight them to help you out. I know that I'm gonna look at 14. It's between 2 arcs and 1 arc. I'm looking over here, 2 arcs and 1 arc. And if you want to go ahead and stop the video now and see if you can do this before me, that'd be great. But I'm going to go ahead and help you set it up just in case you need that setup. I'm going to go with 10, who's between 1 arc and a square, and I see 1 arc and a square. And then my last one, I'm going to go with 18. 18 is between 2 arcs and a square, and I see 2 arcs and a square right there. So that is my setup. I'm going to pause the video, take a quick pause, see if you can set up your WGU, and see if you can even solve it, and see if you get the same answer that I do. All right, so hopefully that was a quick pause, and you can go ahead and test it on your own. I'm gonna go ahead and set up my WGU. So from here, I know I have my first and my second shape. I'm gonna say my first shape is here, just because that's how I like to have it oriented, left to right. My first number that I'm going to choose, you can pick any number, doesn't matter which number you chose. I'm going to pick 10. So 10 becomes 15. So for me, I have the orange sides first. So I'm going to make those orange so I know what I'm talking about. And then the number that I have to pick from here, I have to pick 14 because that corresponds with X. So I have to pick 14 into X. And those, of course, are the yellow sides. So I'm going to go ahead and make that yellow, yellow. We're good to go. All right. Now, if you cross multiply and divide these two numbers, you should get 10 times X, which is 10X, and then 14 times 15, which is 210. Then, of course, dividing both sides by the coefficient. In this case, it's 10. I can actually take out these zeros, make my division a little bit easier, and then 21 divided by 1 is just 21. Perfect. Now, here's another thing that I like to mention. These first proportions, if you wanted to, you could reduce them. I noticed that 10 and 15, 8 and 6, they could both be reduced. These can be treated like fractions. If you wanted to reduce them to make your multiplication easier, you could. You would just have to rewrite the WGU all over again and then cross multiply and divide. You'd get the same exact answer. All right, so what I want you to do is, again, pause the videos and try and solve 9 and 10, and then come back and see what your answer is. And then when I come back, I'm gonna give those answers to you. All right, hopefully that was a good enough pause. I'm gonna do these last two kind of quickly, only because I'm assuming that you paused the video and got your answers. So I'm gonna say that X, that's between 2 arcs and 1 arc, 2 arcs and 1 arc, is gonna correspond with 24. Or I'm sorry, wait, that's 3 arcs. Sorry, I missed 3 arcs and 1 arc. So 3 arcs and 1 arc. And then I have 21. That's between 1 and then 2 arcs. So I'm gonna put that right there. Cool. Now I have that set up. This is my first shape I've decided, and my second shape that I've decided. Now again, you could have gone either way. WGU setup, just like before, first, second. I'm gonna start with X, and that becomes 24. Then 28 becomes 21. Now I can cross multiply and divide both of those just like this. So 21 times X is 21X. 28 times 24 should have given you 672. Divide this both by the coefficient of 21, and that would have given you 32. Perfect. And just as a reminder, so I stay in the habit, I'm going to highlight these two to make sure that I know the difference. All right. So hopefully you got 32 and you did yours. Let's take a look at this last one. Now, what's unique about this one is that we have corresponding sides that are also congruent on the single shape. So this is my first shape. This is my second shape, but watch this. If I chose 16 to be my first shape or my first side, I technically have a choice because it's between 1 arc and 2 arcs. Both the 5s are between 1 arc and 2 arcs. So both the 16 and both the 5 are technically corresponding. You just get to decide which one's which. Same thing goes for the 30. 30 is between 3 arcs and 1 arc. So is this one. So this side and this side both correspond. Now, if you notice, this second side doesn't actually have any information, but you would know once you figured out what X is, you would know what this missing side is. Okay, so let's go ahead and take a look at what the answer came out to be. So I'm gonna go ahead and put down first and second. So my first shape, I'm gonna choose 30. And 30 becomes X. Then the other side that I have is 16, and 16 becomes 5. All right, now cross multiply and divide. 16 times X becomes 16X. 30 times 5 becomes 150. Dividing both sides by our coefficient, which is 16, leaves us with, it's actually a decimal answer, it should be 9.375. All right, so hopefully this gives you a better understanding of the corresponding sides, corresponding angles, and how you solve for missing information on similar figures. But as always, if you have any questions, come see me in tutoring.